Okay, today we are going to prepare a certain experiment according to density, according to pressure, and other science items. First, we start from this one. As our target is improvisation, you see this one is a normal plastic glass. You can find anywhere in your store. So we have the straws. We may have even this, and we may have the water. If we pull the water in the glass and try to fill, up, and we cut our paper. And put what will happen, what's gonna happen. Wow, you see, wow, it can fall down. Well, we can try this air pressure experiment. First, filling the water inside this glass, then put up a paper and try to put up on this glass and fill the water in this glass, then reverse our glass like this. I think everyone knows, like, when we hold this one, nothing will happen. Then you can put here. Okay, then we can pull our paper. Oh my god, you can't pull because it's so wet. Oh my gosh. Oh my gosh. That is black. Okay, well, actually this experiment is so difficult to do, and see the paper wait before you bring out. Another is we have the water inside. We have to straw. We can cut in between so that you can get out. And this one, as long as it is. So let's try to put this one in the water and then blow up here up and see what happened. Let's see this small one. When we try to put the distance between and this straw, and we must sort the length one. Okay, the length one, you see. So we may try to pour out directly and easily, like this. Like this. We are going to see how we can suspend a kettle in the air. Here we have a whole kettle, and here we have a table. Here we have chopsticks, and here we have rubber band. So how can we suspend this one in the air, and what do we really want to show? As you can see, we can suspend this one, and you can feel the force on this arm. So if we try to cut one chopstick and touch on this long one, you see this is like a half of it, and we try to attach them with this rubber band, we can find something like this. Then this is our kettle. We can put this short on this short hand like this, and we can try to let the table handle it. Wow, it can be suspended. So why this is suspended? Notice that the mass of this, the weight of this kettle is under the table. So that's because the kettle center of gravity is directly below the support of chopstick, where the chopstick attached on this table. So here we did the center of gravity. Well, as we can see, we have this one's aluminum cup, like same like this. And if not possible, maybe difficult, we can remove this cover such that you can remain the original aluminum. We had the straw, plastic straw. We had the tissues, these ones. We had the balloon. Then, as we can see, the balloon and the straw, they can bend the water, as seen. They can attract the aluminum, the metal. So, what is the phenomena behind them? This is called electrostatics. What is the phenomena behind it? When we rub this straw with using this tissue, we are creating the charges. Now, as everything has all charges, negative as well as positive, when we rub this, the negative charges are produced and moved to outside this straw. While this outside the tissue, it is produced the positive ones. And when we put together a metal like this one here, a contact, it produces positive side outside to be attracted with these negative ones produced on this straw. That's why when we put this tissue near this one, instead of rolling towards this tissue, it goes another direction. That's why it has outside the positive charge, as well as here we have positive charges. This experiment shows that how we can grimp these grains of rice using this tube. So we can pour the rice in till it goes up. Okay, and you can put our chopstick inside and full of these grains of rice. Like this. Then maybe use this one to pack. And fill again. And now we are ready to lift our chopstick without let down the tube. So let's try it. Okay, we can raise it like this. So we can lift chopstick together. So why? This is because the friction force between the rice and this chopstick makes this chopstick not to come over alone. So it gathers with this rice together. Here, testing a metal, we can use the spoon, any metal, or even the paper clip, or even this one, but we can first remove as aluminium metal. Now if we try to put on my tongue, I can taste nothing. But if we put together this and the taste, let's see. Oh wow, so bitter. It's so bitter. Now these ones are considered as the conductor, electrodes, and my saliva on my tongue is considered as electrolyte, liquid able to conduct electricity. Now this combination of the saliva and these metals as the two electrodes make a battery, and the current is considered as the bitter taste. So in that case, we can test the metals able to conduct the electricity. So let's try to cut this one. It is a milk bottle, and we can put inside a plastic glove and cover outside and try to bring out this glove. Okay, here we get. Okay, can try to bring out it. But it is so difficult. So difficult. Why it can't come easily? It is because the air inside this makeup between the groove and this cup is so tight, because here we covered. That's why from outside you can't pull out this groove. This experiment shows how we can lift our jar using our palm. As you see, if we try to lift this, it can't. What kind of thing or tree you can use to lift this one? Here we have hot water. We can pour the hot water in it and see. This is hot water. Can shake it. Oh, shit. Okay, let me try this one again. See, it's hot. And you pour it. See, it can stretch itself. See? And we left it. Yes. It can work. Can lift it. Now, what is the phenomena behind this one? See, at first time we have poured the hot water inside this one and pour out. In that case, the air inside was so hot. After instant, the vapor inside becomes so cool and becomes water, liquid. And then if the hotness becomes coldness, the pressure inside decreases. Then the pressure outside then increase. That's why it can swing this bottle inward, and the bottle will swing my palm. This palm seems to be a good seal to the bottle here. So it seems like my palm is sucked into the bottle, but it's not. Instead, is the bottle which is strengthened and stretched to my palm. So here, it's the change in pressure which can act on this phenomenon. Like this, in that case, we will not use the palm, but maybe the okay now we use this one to close. Now let's see where the distance is. The distance is here. Still this up is long, so let's wait and see it will happen. Wow, it's still again stretching, 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 and I can see that even this one is going inside. And instead of this one, you can again even use an egg, a cooked egg here, but without shell. Well, okay, that's it. Wow, during experiment you may have the accident, like if you put this cork, it can be inside, so you see it can't come out, so you guys, how can we pour out this one? So everything you need is a cloth. You can cover out this like this and try to pour this in, try to bring it out. Let us try and see. And try. Yeah, can you bring it out? Yeah, can you bring it out? Why? Can cut this paper. Like this. So like this. You can half cook the egg. What we have is to uncover it. See, after removing the cork, our egg, this is empty, and we will need this. and then we can pour this out in, and we put our egg. See guys, why? Check it out. So how to bring it out again, because it can't come out. It can't come out. It can't come out. How to bring it out? Maybe same phenomena. Let's try and see. Pour it in here, and why it can't pour it in? This system is closed. Let's try another way. Oh, it can come. Okay, here we have cold water, and here we have glass. So let's pour the water here and see what will happen. See? It stops. Why? This is because the equilibrium of pressure, the pressure outside pressing this water in glass is equal to the pressure from the weight of this water in this bottle. This is cold water, can I call it, and it's cold water. If you don't have this water color, you can even take the vegetables and the flowers and you can sweep it out and can put there and you get the color as improvisation. Can mix, produce the strong color of cold water. Here we have hot water. And this is cold water. And we can use the plastic here, the plastic cover. Okay. Let's put here. See what will happen. Can take our paper. See what is gonna happen. Okay, it can mix and change the heat. So let's try another one. Here we'll put cold water. We got our cold water. For here, our water. for this water, this cover. Reverse. Okay. Here, try to draw a cover. And let's see what will happen. Okay, see, it can't mix. So we can create our colors, putting the colors. Okay, the yellow color, put it here, and see. It's holy water. Okay, yellow color. Okay, can try to heat the water. Cold water here. The hot water here. Yellow. See, you can create a yellow. And color using flour, and then put our cover here, upside down. This, and try to pour. We can see the water up is so hot and down is cold. They can't mix. And the color, see, they are different. Why then they don't mix? Okay, we can have cold water here. We can put the ice inside this cold water and see what will happen. Okay, it floats. What about if we have hot water? We put our eye. See, it can float. What will happen? Oh my god, it's finished. and the water becomes cold. Why? Okay, let's see. Can you see? Can the burn? Let's try to pour water here and see. See, no problem. Guess why? Here we have water in plastic bag. Can you see? Can you touch it? So we have here a torch. You can write it here as light source. So it's uniform. White right, red right. So the light is uniform. So let's try to mix in with the milk and see what will happen. See, milk. Okay, this. Okay, we can see near the lights, the source of lights, considering the sun. It's bright from the white light, then blue or violet, then green, yellow, and the last red. So from this we can see that the red color is far away from the source. It's because it has a long wavelength, so it can travel and not deviated by the molecules in the atmosphere. Here in this water we have mixed with the particles of milk. Then from white light, the blue one will be reflected much. That's why it will be near the white light or from the source, and the red one will be far away because it will not be deviated by the molecules of the milk. Yeah, we can see. And just this is considered as the atmosphere. When the sun travels toward the earth, the light passes through the atmosphere. And the atmosphere is mixed with the gas and dust. Those dust and gas are considered as the milk we have put in this water. Once while morning and evening, we can visualize the reddish. So the sunset or sunrise from the horizon. That's why we can see far away before the blue one. And during the day, we can observe the blue one because sunlight are direct projecting to the earth. And we know that blue color has short wavelength and it will be much deviated by the particles in atmosphere. But red one, because it has long wavelength, it will continue beyond the blue ones, as just we observe in through the bliss. The blue one here, it seems to be bright too, as it has high energy and high frequency, like violet. Here we have cold water, this dish. Here we have the brick. Here we have the aluminum can. So what happened to this one? And how this handle? So let's pour cold water a little bit, just enough, and fire Bunsen burner. Then try to heat this little water, and guess what will happen? What will happen? Can you get some vapor? Hear sound? Some vapor. We are going to drop in this cold water and see what will happen. Okay, let's do it. Wow. Can you see? Pressure. And then how can we bring it at normal condition? Let's try and see. I pour again a little water. Let's open. And do it again and see. Then if it is open, if it is closed, in this experiment we need, here we have water, here we have egg. Can drop it, can sing. So without touching inside the water, how can you pick up this egg? So we will need the salt. Can we put the salt? Check it out. Check it out. Okay, I can pick my egg now. It's up. Wow. Then Y, density. In this experiment, I will need the egg, raw egg, and the bottle, plastic bottle. Have the egg here, the yolk and the white. So the question is to separate the yolk from the white. How? So I will need this plastic bottle so I can squeeze it and then put it here. Okay, and see, like this. Can squeeze and let it. Now, wow, I can get my yolk. Okay, perfect. And the white stay here. Then even if it is improvisation, you have to clean up. Here we have a certain cup or a bottle. We can create a hole. One just here. Hole. Okay. Then we can make cup like this, but remember we have created the hole here. So here we have a straw. We can create a U-shape straw. U-shape. Okay, here we have an empty cup, and here we have our shaped straw cup here. So let's pour the water and see what will happen at this level and at this level where the straw reaches, and at upper level. What about this level? Nothing can come. What about this level? It can come. The level where the U-shaped straw starts. The upper level, yeah, it can evacuate the water or water. Till the water finished from the bottle. So why? Once the water reaches the level of the straw, the pressure inside the straw will push the water to come out, and it will continue because the pressure outside, which will still and continue to press on the level of the water. I hit here. Now, see what will happen. Can burn. Can burn. See? Can burn. Now, let's try to put the water. Let's see. Okay, we got here the water. So let's try to put on fire and see. You see, nothing can happen. Why? So here you go. Want to color the water. And pour hot water. All right. Hot water. Here cold water. Cold water, hot water. If I mix them, will they be mixed or not? Let's see. I can use a certain card like this to cover hot water. This is hot water. We try this. And try to move our card. Our card. Wow. Let's see. Wow, they can't mix. Why? Because the density of these waters are different. The cold water has a high density rather than the hot water, which is having low density. So it will stay separate, no mix, you see. Yeah, perfect. Another experiment is this one. You see, plastic bag with water. I can introduce some pin materials and the water will not fall out. See? Why? Two reasons. One is a friction force between this pencil and the plastic bag. Second reason is surface tension of the water. Well, here we have a bottle. I can put the water. Okay, tea here. I have a straw. The level of water is here. I have 2 straws. Okay. This one I will introduce steel inside. I will try to close. The small one on just on a level of water. So we can create a fountain in this bottle. Let's try to boil. Well, what is the phenomenon in this? When I close this system, this one is open. When I blow the air inside, so the air give out the pressure on the surface of this water, and then the water will be pressed and pull out through this straw. So this experiment is perpetual motion with a hose. This is a hose, a certain tube. So let's pull the water in this bottle. Okay, till up. So how can we, this is empty, evacuate this one? It can't come. Let's try to you see, when we give a little pressure, to this hose, the water continue to come. So it can evacuate the water from this water to this one. See the level? Diminishing. So the level is here now. So what's happened? We have to evacuate the vacuum from this hose, from this tube. Then the pressure will be pressurizing on a surface of water. That's why the water can continue to pour in this. So here we are going to test the magnet characteristics. This is a spoon. These are paper clips. It can't attract. So here we have a little bit magnet. Let's try to pull in one direction, not like this, but like this. Like this. We are trying to magnetize this spoon so it can become magnet to attract other metals. See, it can attract. It can attract. It can attract. So how to make this lose the capability of attracting? You do like this on a table. You shake and try it again. So it can't. Okay, here we have paper. I can cut. Or we can use even the newspapers. Can cut. Like this. I can wet this one to the water. Can wet it. Can wet it. Can wet it. Okay, ready. And I can pour the water here. Okay. Then I can put my papers. Like this. And this. Then I can put my card. And a card you can find here. Okay. Then what will happen? I'm going to raise this one up. It will raise it or not. Let's see. Wow, we can raise it. While breathing, we breathe oxygen from outside to inside our lungs. Then when we breathe out, we let the CO2 go out. So I will not talk too much about the oxygen and the CO2, but I'm gonna show you how we can make the lungs model. So here we need the plastic bottle. I will need some kind of balloons. I will need some tube like straws. We need the membrane. We need maybe rubber band, and I will make from this straw a Y shape like T-Loy tubes. And I will use membrane as the diaphragm, and I will use, of course, the pump as the mouth to put in and pull out the air. We will cut it, and here we, after introducing our Y-shaped tube, we have to tie such that no air will be released through it. Down, after cutting, we make the membrane here and the tie. After making we can get something like this. As we can see, this is considered the mouse. This is considered the theory is in the form of Y shape, and the balloons are considered the lungs. And this one, the bottle, is considered as the chest, while this membrane is considered as diaphragm. So, what will happen then? We take a look on the balloons, and we take a look on the diaphragm. What will happen? We're going to let the air enter inside there, and you will tell me what will happen. You see, the balloons are containing the air. In our case is the oxygen. Then the diaphragm is getting pressurized. Then when we pull out the air, you breathe out, the air from the lungs goes outside and diaphragm released. Okay, so when the lungs are full of air, the air inside the lungs will pressurize the chest or over other parts of our chest, and because the diaphragm is stretchable, it will stretch down to the abdomen, and when you release the air outside, the diaphragm will be released. So you guys, this is how the lungs are working. Once we have something in the tubes, we will need to hand them where to place. So we have to create this tube lock using the plastic bottle. What we do? There are paper and we draw on. Here we get our measure. Then what we need to get the holes alongside these holes. Like this. Then we take our bottle, then we can draw, and then we create the hole. Okay, we can get our hole, then we can keep safe. Yeah, safe. In a laboratory, I will need to improvise a certain burner using petrol, using kerosene, using alcohol. From aluminum cup, I can first cut. Okay, there I go. And this one I will introduce inside. And after I got something like this around here, I'm going to introduce some hole like this, like this. Okay, I got the hole alongside. Okay, we got it. So safety is number one in lab. I gotta pull the tunnel. Okay, we got it. Can boil my water. Okay, after the fire will come flow out to the other holes, outside the holes. And my water is going to boil. Wow, I can get my boiled water here. So that's it. Here I have a business card. Here you have 500 coin yen. I will put my business card here and put the coin over here like this. See, the coin stay. This is inertia. Okay, here I have balloon and I have a well pin. What will happen? Why, it bursts. Wow, can do it. Real. If you can observe, this side and this side is not very high stretched. The friction force between spin load and this bar here, it can be different from this side. So from a bottle we can make a wind, a van. Just cut. Okay. Wow. We can connect to our motor. Okay. Okay. Can put our fan here. Okay, like this. Then connect to our generator. See, it can move. And enjoy the air. So this is how the motor works. It can make other things to move, like this fan. We may make and cover our lamp. Here we have a lamp from electric shop. Can one end cover here around. Like this. Another end will be here. Okay, we can make our lamp. Let's test it if it can work. It works. It works. Okay, I will make a battery handle from plastic bag or any carton. A box. Here I get, and can put my battery to measure. Maybe here. Maybe here. Okay. And then okay, here I get parts that I will be using this and some paper clip to make switch. After that, we get our battery handle. One terminal we have paper clip, and another terminal we have another paper clip. Inside it looks like this, and the outside look like this. Okay, we can put our battery, this, and we can test our lamp. Okay, it lights. It lights. We may look around in our environment, maybe at a mechanician or electronician, and we may hunt such that we can get a non-working machine and we break it such that we can get a certain motor. We can use other source of energy like batteries, and we make this move. After this moving, it will produce another energy to carry other things, to let other things move, like vehicle, like motorcycle. Returning to our motor, our motor can move. The test, yeah, it is moving. High speed. Now we can connect to other machine, then this one can carry those machines. So the motor again can make other things to move. If we connect, we can connect our the machine like this, and we connect. It can move. This machine has the gears, so we can create our own gears, maybe using this. It has the gears. Can use type of these. It has the gears. Can make things like this. Okay, they are connected, and this will connect to the other motor. The motor will move all this. Now we want to move our machine. I load output in the direction. Now we can connect to our machine and connect it to the power. One here, another one here. So it can move so quickly. Like this. Wow, maybe we can again create another energy from maybe this wind turbine. So this is how it works. Okay, here we are going to distinguish two kind of things. One is electricity, another one is magnetism. For example, we can use the electricity to provide magnetism, and we can use magnetism or magnets to produce electricity, vice versa, just vice versa. At first, we start with doing and showing how a motor works. A motor works in form of when we have a battery or any other kind of energy producer, and we have the connector wires, and we need some kind of magnets like these ones, and we will need, of course, the paper clips, and we have to produce our moving item or motor like this in this wire. First we roll it like this. And like this. Okay, tie it the same. Like this. Like this. Okay, then we will need a paper clip. One attach here, another one attach here. Okay. Then our battery is here. We can connect both on. Another thing to make attention, we have to take care on this motor. How we have to rub, because this is copper wire and it has some insulator here, the color. So we have to move one end whole, but on other end one part, not the whole ones. Here we have to move everything. Okay, on another end, one part. Okay. Okay. Okay, then connect and see what will happen. And connect here. Then after, we have to move to put our magnet under here, so the motor can work. So this direction from like this one, so we can change another direction. So let's maybe move here to here, and I think it will change direction. And here, okay. Okay, to change direction. Now it is coming like this. If I give direction of this one, it is counterwise, like this. So using electricity as a source of energy and using magnets, it can produce and it can move a certain object like machines. From the Fleming's law, the current is coming in this direction. This is the current coming in this direction. The motor is moving upward, downward, like this direction, the force. And the magnet will move on another direction. If the force is moving upwards, the current is coming horizontally, so the magnet field will come like this, in this direction. And now we are going to create an electromagnet. What is electromagnet? Electromagnet is a device when you connect to electricity, it can get the magnet's property. It can attract other metals. So actually this is a piece of iron, so it can't attract other metal. It can't, like this paper clip. Or we may even use iron. See, it can't attract. Let's connect it to a battery and see. Only the iron metal, if it can attract. You see, it can't attract. It can't attract. Now, we may have a wire. Then we make round on it like this, tightly. Let it wound around and you see. And you see it can attract. See, it can attract. Using a big metal like a nail and using many coils around it, it will increase the capability to attract. So this is how the electromagnet works. We have electricity and we can make a certain material to be like a magnet. Okay, from this I make a shape of this. You guess what I'm going to do? Maybe not a prime, but I'm going to make a cow using a motor, like this, using a motor, and I will make it to move. Next step, I'm going to introduce my tires like this. like this. And like this. Make sure that they are moving easily. Another step, I'm going to create the gears. Okay, here I'm going to test my car. Here is the whole car, and here is the connection. Like this. Welcome. Wow. Welcome. Wow. Welcome. Okay, here what is going on. The whole vehicle is here. This is battery. So down here, I connect a small motor having a gear and another gear connected to the tire. Then when we connect to a battery, this gear will push the tire gear, and it will remove the behind the tire. Once the behind the tire is moving, when we put on ground, so the friction will act, and the front tires will go. That's it. And the electricity is there. We can check that the electricity is there. The lights.
Cannot find a cell.
Hey, you are using what, water? Yeah, my crossway is difficult, man. Very difficult. Even for me to do this simple experiment, it takes me 20 minutes. Okay, here I have a model. This model will show how the lungs work from plastic bottle. Inside I put a shape tube and two balloons, and this is considered like mouth and nose. This is the head person, and this is the diaphragm. This is membrane. Now, from the brain will command the muscles to contract. When it contract, the whole air will go out from the lungs, and the diaphragm will come out. And what will happen if we release? If we release, we let the air go inside in lungs, and the plastic will be, the muscles or the chest will be released, and the diaphragm will go upward, will go in. Let's try again. Just go down, and we release. The air come in, inhaling, and diaphragm goes up. I do it again. This, go down, and no air in the balloons. Exhalation, then we release, inhalation,
coming, and diaphragm go up, go in, and air full of the lungs. Apart from using this chest, we can also use this diaphragm. Like when we stretch, you see the lungs are full of the air, and when we release, the air evacuate like this, like this. Trick number 1. Here you have an empty glass. Here you have a chopstick. Here you have spoons or forks. Who will think that this is possible? I get like this. Using a chopstick. Check it out. I can balance my forks. Okay. Tell me what will happen. We provide how we can produce electricity or any kind of energy flow using the fruits. Here I have apple. Instead of, we may even have the lemon, we may have orange or banana, any kind of fruit. So here I will cut this into 4 pieces here. Now here I will need 4 nails, 4 pieces of coins or copper pieces. First of all, we have to use, I will first use the nail and this aluminum coin. One side here, coin on the side, respectively to other pieces of apple, nail and coin and coil. Okay, I'll connect this one here on nail, another one coin to nail, and then coin to nail, and coin to nail, and last coin to nail here. Here you have stopwatch, so I will pull out the battery, then I use my improvised battery and see if it will work. You see, it doesn't work. Let me connect and see. I will connect here and here. Hey, it doesn't work. Okay, again I will try. Instead of using this coin, I will introduce metal copper plate here. Let's try it again and again and again. The test. It works. So check it out here how it works. It works. You see, it works. The watch can work from the flute's electricity. Perfect. You see, it didn't put any battery, no battery, just using this apple. Okay, like this. It can work. Yeah. So let me see what kind of current is flowing. Oh wow. You see, before I will use galvanometer. Before connecting, it is in 0. Then when I connect, can you visualize the change? Okay, 0.1. So the current is flowing. Then test this lamp, but it can't, I think. The lamp can't light because it will need a lot of electricity. Okay, we can say that the flutes can produce electricity when we use the nail as iron electrode and we use copper as another electrode to change the electricity from electrolyte, which is this juice flute. So we have visualized that this aluminium can't work because maybe same type of iron, but when we change the electrodes, the copper and the iron, or the copper and the aluminium, can work because they have quite different material. Now I'm at the final stage, ready here.
Okay.
Oh!
Now it works.
Wow, it can go. Wow, it can go forward. Wow. Yes. Even if it meets with the obstacle, but it can go forward. Wow. Forward. So here what is going on? We have to take care on the propeller, because if we don't care, it can move in circle motion, or it can move forward, behind. To make it forward, to move forward, we have to take care on making propeller one behind another with a certain angle, like this you can see, such that one push the water downward, another one push water upward, then the boat will go forward.
So using aluminum foil, I will demonstrate how electroscope works. Using the plastic bottle, I will demonstrate how electrons or protons can make the aluminum to repel each other. I will cut with this. And like this, I can get two aluminum foil. Okay. After, I will get my aluminum foil, try to introduce on this iron wire. Just here, like this, there are two. You see? You see? You see? See? The aluminum foil can repel each other like this. Like this. And let's try this again. You see? Repel each other. Repel each other. When I touch here, they attract each other. Why? And I remove. They repel each other. Why? When I bring, so they attract instead of repelling each other. Okay, what I mean, we have here our electroscope. In this conductor, in this wire, we have positive charges, and on aluminum foil we have positive charges equal to the negative charges is equal to positive ones before charging. Then I bring my straw here, around here, charged. This straw is charged negatively around here. When we put close to here, you see these negative charges will push the negative charges on this conductor through this aluminum foil. So like this one will move, and they will come to concentrate on here. What will happen? This part will go away because they will repel each other. Now, let's see what will happen if we put our finger or our arm here. Our arm is charged negatively and positively. Both charges, everything has both charges. But it is natural because we didn't charge it. If we put our arm here or our finger here, and we are connected to the ground, the phenomena is called grounding. The arm is here. The negative charges will be coming from the foil, the aluminum foil, and will come to my finger, to my arm. They want to go to the ground. After removing then our straw and our arm out, and these negative charges are from here, aluminum foil, like these ones, like these ones, like these ones, like these ones. Okay. And we remove. So from aluminum cap and the motor, I will make a Van de Graaff generator. This phenomena is showing how thunderstorm works. It's almost done. Here I have my motor, and here I have the pulley, and I have used this scotch to connect this pulley to this motor, and I have to fix in the right way. Okay, it's almost done. Here I connect to motor. This is motor, and I will connect to battery, and you see I connect to the grounding wire. This wire is touching on the rope between the motor and the pulley, and I connected another wire, this one, to the top of the rope. It can touch a little bit, and when I turn on battery, this motor will turn this rope around this pulley, and these wires will touch on the rope.
I have created an aluminum cup and putting some foil, aluminum foil, to test if the charge are available. I will put here and such that this one will attach inside. Like this. Like this. Okay. Let's use this battery, 2 batteries, and see if it can work. See, it can't work. It can't work because it is very heavy. We need a battery like this. We can increase the voltage. Okay, let's test and see. See, aluminum foil pair each other, means that charges are there. So I can feel electricity there. We can also test using our electroscope. See, electroscope also repelled each other. Away again. Repeat each other. Away again. So the charges around here. When we connect to the power and we connect to the ground, we have something like this. Inside you have rope. Here we have this brush, connect to wire to the ground. Here we have motor, and here we have pulley, and another brush here touching on this metal. When we connect to the power source here, with the friction between this rope and this grounding wire, with the power source energy, the production of positive charges will be produced around this side if the pulley is moving in this direction, and leaving here on another brush, the positive charges will distribute on this metal around here. At return, it will meet on this side, this brushing. Ionization occurs, means the charges becomes ions, and the production of electron occur at this side. And again, when it reaches on this brush, and these negative charges go and neutralize where positive charges were coming from to the ground. And when you bring something charged negatively near this ball, the electrostatic force will occur between these charges. When we connect to a neutral object, what will happen? The positive charge ones will push the positive charges in this body, and the repulsion will occur in that case. This generator is explained by the phenomena which is called induction, charging by induction. And with these two phenomena can explain the lightning. And
thunderstorm. What will happen in thunderstorm? When we have cloud here, this cloud has both negative and positive charges, but the charge separation will occur because of the wind moving this cloud, and the pressure in this cloud is not equal, where we have the light ice and the heavy ice. Light ice normally has positive charges and heavy ice have negative charges. So the heavy ice will sink and light ice will float, producing positive charges up and negative charges down. When we get more and more negative charges, these negative charges will induce the ground, and the ground has both positive and negative charges. When these negative charges induce, so also negative charges will stay at bottom of the ground and positive charges will come at surface. And the electrostatic force will occur. Once the electrostatic occur, these negative charges will produce what is called a step like zigzag directions to bring up these positive charges. When this step meets with a target like a tree here, and the tree is full of charges because of the water, it will be easy to struck by this lightning. And when enough charges are accumulated, this step will be connected to these charges and produce the huge energy from this step will come to connect with these charges, and lightning will occur in the form of light, and we see the light before the sound because of the speed of light is greater than the speed of sound. So this is lightning between cloud and ground. But we have also between cloud and cloud. And we have also between cloud and air. When ionization of air between the lightning of cloud occur, it is struck